Hello. I think everything's should be set up now. Um, how many people? There's people still come. Oh, there's a bunch of people still to come in. Does everything seem okay? Do you hear me? Do you see the desktop now?
Yep.
Yeah.
Yep.
Okay, great. Thanks. Okay. All right. So today we're going to do more stuff about arrays. We got one more topic to do about arrays, and there's a reading assignment. Next week, we're going to start talking about classes, the object-oriented part of Java. Okay, so that we'll start that next week. So there's a reading assignment from both the books, uh, a brief reading. It might look like a lot of reading, but it isn't as much as it looks like. Like this first reading is just sections 9.1 through 9.4. If you go to this section, it's only actually like 4 or 5 pages. It's actually probably not even 4 or 5 pages. So it's just that much. Okay, so it's like a half. It's just it's not very much. Okay, so that's a short reading. So the first reading is a real short one. The second reading is a longer one. The second reading is this chapter. Okay, so this is a pretty long reading. Okay, that's the main reading. Okay, and then there's another short one in here. Okay, and this one's not, and this is the one that has practice problems in it. So this one's it goes over what the other two readings are about to some extent, but it's got these kind of nice problems built into it. So this ends up being kind of a summary of the other two with problems in it, and it's not very long. So the main reading is the middle one, this one here, the chapter 10. That's the main one. Okay, and we'll talk about that stuff next week, and we'll be talking about this for a couple weeks about classes and objects. Okay, and what I want to do today is, well, first we're gonna finish this example on searching array. I rewrote the example the other day after class to simplify it a little bit. I think it was overly complicated, so I simplified it a little bit. So we'll look at it again, and then we're gonna look at some examples on arrays and methods. And let me show you a trick. The code for the arrays and methods is up on the website, but I don't have a link to it yet. Okay, if you go up here, this is what we call the URL, the address of where you are. If you shorten the URL to the slash and hit enter, you get, it's like a folder view. You get the folder, because the web server is nothing but a computer with folders. And the slashes, just like on your computer, the slashes, like if I open up my computer, oh, let's see, go to, see, I'm opening folders. Okay, see how the folders have slashes in their name. Okay, so you separate the names of folders with slashes. Internet websites do the same thing, but they use the other slash. Instead of using this slash, they use this other slash. Does anybody remember which one's which? One's forward and one's backwards. Is that the forward one? I think that one's the forward one, and I think this one is the backwards one. Okay, so and just like here, I'm getting a folder view, and I can shorten this to the folder that is above it. Here, the same thing. I'm getting a folder view, and I can shorten it to the folder above it. Okay, and the folder we were just looking at was, well, there's finally switched. Okay, and we were in this folder. Whoops, I clicked 20 times. Okay, okay. Now, the code for all the classes, they're in this folder from class. Here's today's date. Here's the examples we're going to look at today. Okay, so if you want to look at the example, if you want to download it before I get a link to it, you can actually find everything that's up on the course website by playing this game of treating the browser like it's Explorer. Just like Explorer lets me open folders on my hard drive, you can actually open folders on on a web server. Okay, this doesn't work for every website because many websites block this folder view. They don't allow you to see it. So on a lot of people's website, if you try to shorten a URL to the folder like that, you'll get an error message, which is okay. It's not, there's nothing wrong with that. Some web servers want to keep the folders private. So they only let you see the files that are in them. They don't let you see the folders themselves. But I leave mine unprivate. You know, if you want, you can explore the whole website. If you keep going, eventually when you go parent here, you get the root of my website, okay? And if you shorten it one more time, you just get a generic page that says this is the math server, okay? You just get this generic page. You don't see the folders. You don't see the folders that are here. The folders that would be here would be other professors. If you could see the folders here, you see a folder for each professor who's using this server. Okay? That's a little bit about how web servers work. And so in the case of for this class, if you start here, you know, you're looking at this web page. That's the page you're looking at. And if you delete that and then hit enter, now you're looking at the server you're looking at the folder that page was in. See, it was that page there. See, the page, no, I'm sorry, it was not that page. The page is called CS123. That's this page right here. And this page here is the page for each day that we meet, okay? So web pages are just documents on a computer. They're just documents on a computer, just like Word documents or anything like that. But when you display them in a browser, they get displayed in a nice way. Okay, so if you want to see the code, like I say, it's in this folder from class, then pretty much for each day we meet, there's a folder. For most of the days we meet, there's a folder, and there's the code that we're going to look at. Okay, all right. Now, there's where the folder search array is. Okay, want to look at this example. Let me get back to where we were. Okay, so here's the more normal way. When I look at this search array example, okay, I simplified it a little bit. Like I dropped all the while loops. There were while loop versions and for loop versions. Okay, what we're trying to do is we fill an array with random numbers. So this we create, in this case, an array that'll hold 10 numbers. Okay, then we fill it with random numbers between 1 and 100. Then we look for the number here, 50. Is the number 50 in the array? Okay, and we want to know where it is in the array. And if it's not in the array, we have to figure out a way to say that it's not in the array. And there's a couple ways to say that something's not in the array. Okay, like we thought of it as in one way the other day. If I do a simple example, like here's an array, index 0, index 1, index 2, index 3, index 4, index 5. And here's some numbers in the array, like 4, 5, 0, 3, 7, 6. Okay. If you search for the number 4, it's in index 0. If you search for the number 3, it's index 3. Let me put a 3 here. Now, if you search for the number 3, you could say it's at index 3, or you could say it's index 5. That's the first index that appears. That's the last index that appears. So one of the things you have to decide is which you're going to report. If somebody asks for the index, if somebody asks you to search for something, should you say where you first found it, or you should say where you last found it? Either one would be reasonable. And that number could even be in the array another time.
I have a question.
Uh-huh.
It's back on the code that you were working on. I was wondering how you got the random number from 1 to 100 or to 200.
Oh, here, we're just calling a method that does it for us.
So there's instead of having to do that int math, that's just the method, random dot.
Yeah, yeah. This was, remember I said that this is the old way to do it, and we don't have to use the old way anymore. They eventually created a newer way. This one generated a random number between 0 and 1. And then you have to do some manipulation to get it to be a random number between 1 and 100. This
Right.
one, now, real quick, what does it actually give us? Does anybody remember what I told you? This thing gives us a random number between what and what?
0,
9?
99.
99, yeah. See,
Mhm.
so it's just like an array. When you have an array of size 100, the indices are from 0 to 99. When you ask for a random int 100, you might think you got random numbers up to and including 100, but no, you get random numbers from 0 to 99. To make them 1 to 100, I add 1 to them.
Okay. So
So that
that first number is like where you're starting at?
well, not kind of. For example, what if I made that a 5?
That would that not do 5 to 99?
No, no, because see, this would still be what? This gives me random numbers between what and what?
0 and 99?
0 and 99.
9.
Okay, if I add 5 here, what's my final result?
0 and 104?
Yeah, no, 1 and 104. Well, from 1 to
1 to
105.
104?
It'd be from 1 to 105.
If you put a 5 right there?
I'm sorry, 10. Yeah,
Would it
See,
be a 5 to 104?
104, right? Because
You
you would
said
add
it's 5 to
you'd add 5.
104 if you put a 5 right there?
Yeah, pardon me? I could.
Okay. So when you put the 5 right there, it changes the left limit and the right limit.
Yeah, it shifts all the numbers over. See, this is from 0 to 99.
Okay.
So then
Okay.
you
So
would shift that over by 5, so it'd be from 5 to 104.
okay. So that number is like the range.
Yeah, this number is the range, and this moves the
That's
range
tipping the
over.
scale.
Yeah, like
Okay.
what if you wanted the random numbers between? This is tricky. What if you wanted them between 5 and 100? What if you wanted 5 to 100? Random numbers between 5 and 100.
So you go like put a 5 right there and then put 95 in the parentheses?
Yes. Yeah. Mhm.
Okay, that makes a
Yeah.
lot more sense.
Yeah.
Thank you.
Yeah. It's quirky, but yeah, yeah. So you can get any, like if you wanted to range from say 4 to 18, random numbers between 4 and 18, you'd put a 4 here and 18.
14
Pardon me?
or 14?
14 there. Yeah. All right. So it's just, that's just the way they decide to, like if you'd think they would let you put 2 numbers here. And what would the 2 numbers here be?
The starting and the bottom?
Yeah, the starting number and the ending number. Now, why in the world didn't they just do that and make life easier for people? I have no idea why they didn't do that. They just didn't say random int between A and B. Instead, that's random int from 0 up to, but not including this number. And then if you want a different range, you have to start shifting it over by adding something over here. They could have made it real easy. Instead, they chose to make it kind of weird. And that's just, unfortunately, you're stuck with a lot of things like that in programming, where you say, where something could have been made easy. Now, some things in programming just are inherently hard. They just are hard ideas. But then you get stuff like this that could have been made easy, but they still made it hard. They still made it tricky. Instead of giving you the obvious thing, you could just say random int from A to B. So from start, any random number between A and B, but they made it this way. And then this was the older way, which was even harder, where you had this function that gave you a random number between 0 and 1, a decimal number between 0 and 1. Then you had to multiply it by 100 to stretch the numbers from 0 to 1 up to 0 to 100, but they're still decimal numbers. So then you had to do this thing to chop off the decimal part. Then you had to do this thing to convert it to an int. So you had to stretch the numbers to be from 0 to 100, then chop off the decimal part, then turn it into an int. And then add 1 to make it, instead from 0 to 100, from 0 to 99, well, then it would be, it would have been from 0 to 99.9, and now it's 1 to 100. So this was the old way, which is harder, which is even harder. This is the better new way, and it's still a little bit tricky. Okay, but this function, it does all the work for us. You know, it does all the hard work of how do you actually generate a random number in a computer. So we import the random class, we import that, we instantiate a random object, and then we get to use it. A lot like a scanner. You know, remember how we would import scanner, create a scanner. Notice that even nextInt is the same name as what scanner used. You know, if you said scanner.nextInt, you'd get the nextInt from the keyboard. They actually designed the random class to look a lot like the scanner class. They actually purposely did that on purpose. You kind of use random kind of like scanner, but instead of getting your numbers from the keyboard, you're getting your numbers from this where it's as if there's a little guy in your computer who's rolling dice for you. So you're getting numbers from this random generator instead of getting numbers from the keyboard. But they use functions with the same names like nextInt, nextDouble. Okay, so they designed it to look a lot like scanner. Okay, all right. So we fill our array with random numbers. Then we're supposed to see if that number appeared in our array. And here's 1, 2, 3, 4 ways to do it using 4 different, slightly different for loops. Okay. Now, like a minute ago, the one thing we have to worry about is there's 2 things we need to worry about. What if the number we're looking for isn't in the array? If we find the number several times, which answer do we return? Okay. What if the number is not in the array? What do you return? What answer do you give? And if you find a number several times, what answer do you give? So for example, 3 is in the array at location index 3, at locate index 5, and at index 7. Okay, you might return the first index you found, the last index you found, or all the indexes. You might return all the indexes, but you have to make a decision ahead of time. Which one are you going to return? The first, the last, or all of them? Okay, like in the string class, the index of method returns the first index found. The last index of method returns the last index found, and there is no method that'll return all the indexes. If you want to know everywhere in the string where a letter occurred, there's no real way to do that. You'd have to write that yourself if you wanted it. Okay. Okay. So some of these methods will return the first, and some of them will return the last. Okay. So we're going to see that I did this a couple different ways. Some will return the first, and some will return the last. Now, what do you do if you can't find the number? Like, what if I look for the number, what's not here? 6. Okay, 6 is not that, not there, 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 not there. Okay. There's kind of like a couple philosophies to take here. In a sense, there's an index -1 over here, right? That's, you know, it's not in the array, but over here, there's, yeah, if you go below 0, the next thing below 0 is -1. Okay, and there's also an index over here, 9, that's not in the array. Okay, one possibility is when you don't find a number, you could give that index answer, or you could give that index answer. Okay, the idea being, well, that index really isn't in the array, so that's a way of saying, oh, I didn't find the number you're looking for. I'll give you the -1 index, because that isn't in the array. But you could also return the 9 index, because it's also not in the array. It happens to be the length of the array. This array has 9, there's 9 indices, there's 9 numbers in the array. Okay. Now, index of returns -1. When you don't find something in the index of method in the string class, it returns -1. But there are people who sometimes use the length as the signal that you didn't find the number, because the length is also not a valid index, so you could return that one. Okay, and in fact, like here's one reason why you wouldn't want to return -1 as a signal. In the Python language, they did a real clever thing. If I have an array of, say, length 9, okay. Suppose I have an array of length 9 called, I'll call it A. All right. So A0 is the first item in the array. A1 is the second item in the array. Okay. A8 is the last item in the array. So we see that here, like 0 through 8. Python did a really clever thing. In Python, that's not a mistake. In Python, they did the idea that it's like a video game. You're on the left edge. You think of A0 is on the left edge of the array. When you go off the left edge, you return on the right edge. So they think of it as like on a video game where if you go off the left edge, you just return on the right edge. So A-1 actually is this entry in the array. And in fact, A-2 would be, well, you go 2 steps over, but that means you go 1 step over, you're here, and you go another step over, you're here. So A-2 would be A7. Okay. So Python did this really, so A-1 is not a mistake. A-1 is the same thing as A8. Okay. So you can't use -1 as a signal that you didn't find something, because -1 is a way of saying it's at the end of the array. Okay. So not everybody uses this idea of -1 being as a signal as you didn't find it, because in the Python language, and some people want Java to do this, but Java never will, because so many people have adopted this strategy of using -1 to mean not in the array, that they're not going to make the language change to do this trick here. This actually is not it's a popular trick in programming languages. Python is not the only language that does that take negative indices and treat them as starting at the right end and moving left. Okay, so you're starting at the right end and moving left. So this one's -1. So another way to put it would be, this one's the -1 index. I'm sorry, that's the -1 index. Then this one's the -2 index. Then this one's the -3 index. Yeah, so the indices go back over. You can just kind of count down from -1. You have the -1 index, -2 index, -3 index. This would be -4. This would be -5. This would be -6. It can look confusing, but it works really nicely. A lot of programmers love it. They think it's a great trick. Okay, so but then when you use that trick, you really can't say that -1 is you can't really say that -1 is a bad answer, because -1 isn't really a bad answer. You could still try to say that -1 means I couldn't find it, but then you got to be careful, because -1 is really a valid answer. It means it could be thought of as meaning you found the answer right at that slot. Okay. All right, so you have 2 questions. What if the number isn't the array? What do you return? And good answers are either -1 or length. Yeah, -1 would be returning this number. Length would be returning that number. Okay. And if we find the number several times, what answer to return? The reasonable answers are first or last. Okay, those are, yeah, you could return the middle one, but nobody does that. They either return the first answer or the last answer. Okay, let me save that. Okay, now look at the code over here. Actually, let me download this. and open it in Dr. Java. And then we'll look at it on the Java visualizer too, okay? So let's look at what number 1 does. Now it tells you here, it searches the whole array, report the index of the last, this one's going to return the last n found, not the first, and it uses -1 to indicate that n was not found. So I tell you, I specify here which one of these choices each one of these guys makes. So this one's going to be a choice where it's going to return the last one found, and it's going to use -1 to mean I didn't find it. Okay, so how does that work? I make a guess at where the number is, and I'm guessing the number is not in the array. So I'm going to treat where as a variable that holds a guess. It's like when we find maxes and mins. We started off with making a guess at what the max and the min was. So here's the guess. I'm guessing it's not in the array. Okay. Then I go from the whole array from the beginning to the end. See, there's our traversal. Start at index 0, go up to but not including the length. So I'm going from 0 up to but not including the 9. So I'm going across the whole array. Okay. Then I ask, is the number equal to what I'm looking for? Is the array entry equal to what I'm looking for? If it is, I update my guess. So my guess now says, oh, I found it here. But since I continue on through the whole array, where will always be at the last place I found the number. So if I'm looking for the number 3, I'd find it at index 3, I'd find it at index 5, but then I would keep on going and I'd find it at index 7, so the answer would be 7. Because this one keeps on going through the whole array. Okay, so that's a real simple way to do it. Have a go all the way through the array, and have something that keeps track of where's the last place you found it, so then you end up answering where the last place is. And notice if you never find it, the answer is just -1. So that means, see, if you never found it in here, where never got updated, so the answer is -1 to mean I never found it. Okay. Now here's a trick we can do. What if we wanted to find the first time that 3 was in it, we'd want to stop there. We would like to be able to stop the loop. Okay. Now we don't know where to stop it ahead of time because we don't know where we're going to find the number, but we'd like to be able to stop the loop when we find the number. There's a command in Java called break, which is a convenient little thing to use every once in a while that stops a loop. The break command has no meaning if you don't put it in a loop, but if you put it in a loop, it means stop the loop. So what I'm doing here is I'm looping like before, all the way through the array, but there's the potential to stop the loop when I find the number. So now if I find the number, now notice I start off with a guess that it's not in the array. So I do this. No, here, I'm going to stop the search when n is found, report the index of the first n that is found, and use -1 to indicate that it was not found. So here I'm telling you this is how this one works compared to the other one. Okay. The other one searched the whole array and returned the last entry found. This one stops the search when it finds the number and reports the first index found. Okay? But it'll report -1 if it doesn't find the number. So the code looks exactly like this one, except for this new line thrown in here, which changes the logic a lot. Yeah, all the other lines up here and here are the same. You can check. All these lines here are exactly the same as all these lines here, except that there's this extra break in here. But that really changes the logic. That now says, when you find the number you're looking for, quit the loop. So you'll see that this thing jumps you to line 55. See, when you hit break, it just ends the loop immediately, and you go from line 52 to line 55. Okay, so in the visualizer, we can try playing with that and see how it works, but it causes you to just jump out. Okay, Now that has the effect of notice that one little word changes the logic of this thing a lot. Yeah, the logic of this thing changes radically by introducing that one little word. Instead of going through the whole array and returning the last index found, now it only goes through part of the array and returns the first index found. Okay? The break command is weird. A lot of companies won't let their programmers use it. If you've ever studied any programming, you might not know that it's actually common for companies not to allow people to use break. Because if you use break too much, you can write code that's unreadable. Break is something that's very easy to abuse. Okay, it's real easy to throw breaks into your loops and end up with code that's almost impossible to debug or understand. So it's actually fairly common for companies to have a rule that you're not allowed to use break in your loops. Okay, so it works nicely in simple examples, but when you start writing complicated code and you start throwing breaks all over the place, you get code that nobody can read. They actually call it spaghetti code because it becomes a big tangled mess. Okay? So break works beautifully on a simple example like this, but it's very easy to abuse it, so it's not allowed in some companies. Okay? All right, now let's try another strategy. Okay? This one's almost the same thing. This one's going to use length as the flag that the number wasn't found. So instead of having this extra variable, the idea is, why don't I just use my loop variable? See, if you go through the loop all the way to the end, remember the loop variable will end up here. Remember, this thing fails when the loop variable gets to length. So if you got to the end, it's because you didn't find the number. So in a sense, this guy's redundant. Okay, I don't really need him. The I will tell me if I didn't find the number. Because if I got through all the way to the end of if I got all the way here to the last number here, so that the loop dropped out at the end, that means I never found the number. Okay, so this loop here, this loop here is going to use I as the flag that I didn't find the number, and I want to use I equals length as the flag. But now here's a trick. Normally, see, in this loop, I lives in this loop, so I disappears when you get to there. See, I is part of, see, it's declared in the loop, so it disappears here. Now I want to use I outside of the loop. If I want to use I outside the loop, I have to declare it outside of the loop. So this is a little trick. You have to, if I want to use I, just like, so now I is like, see, where was declared outside the loop so that I could access it outside the loop. Okay, I'm using it inside the loop and outside the loop. Now I'm going to use I inside the loop and outside the loop. So I need to declare I outside the loop. So I declare I outside the loop, start at the beginning of the array, go all the way through the array until the end. If I find the number, I break. And when I break, I is where I found the number. See, I break when I find the number, I is where I found it. So then I have to check, is I less than the length? Because that means I found it. If I is equal to length, I did not find it. So the logic's a little different. The slight advantage of this is I save one variable. For what it's worth, I'm saving one variable. I don't need this extra variable where along with the loop variable. And for some people, this is perfectly reasonable. Go ahead and use I as both the counter for the loop, the index of the array, and also the thing that tells me when I didn't find what I'm looking for. When I hits length, that means I didn't find what I was looking for. Okay, so, and I only get to that because I never did a break, because I never found the number. So then so if I get to length, that means I didn't find the number. Okay, and then here's a real quirky way, here's a way of solving the problem that doesn't use break. Okay, instead of breaking the loop when you find the number, add more logic to the add more logic here. So look down here. Here's an extra piece of logic in the for loop. Start the index at 0. You're going to increment the index. When do you stop the loop? Well, if you get to the end of the array, you stop the loop. And, well, no, actually, when do you continue the loop? So, you should think of this as, remember, true means continue looping. False means stop. But true is what we're really interested in. When do you continue looping? You continue looping if you're not at the end. See, you're not yet at the end. I is strictly less than length. You're not at the end, and you didn't find the number. Okay, so not at the end, didn't find the number. That means I have to go look again. But notice that there's nothing to do in the body of the loop. This is very quirky. This for loop has no body. There's no notice there's no braces. The for loop doesn't even have a pair of braces after it. If I wanted to, I could put a pair of braces here, but there would be nothing in the braces. There's just a semicolon. Okay? The only thing in the braces is the semicolon. We call that an empty for loop body. This is a quirky piece of code. Now, the advantage to this code is I'm not using break. The disadvantage of the code is I have to write something really kind of obscure. Okay, I have to write double condition here. I write a double condition here, and then I end up with nothing in the body of the for loop. But I do have the slight advantage of not needing a break. To some people, this is better because the logic of where I'm stopping the loop is right there. When people analyze programs like when a company's writing programs that are thousands or hundreds of thousands of lines long, they tend to use automated systems to analyze the code. Okay, so they have the programs analyzed by automated systems. The automated system has a hard time figuring out what that break means, because that break means something involving this if statement. So you have to really work hard to figure out what that break really means, because then you have to figure out, well, is it in an if statement, or is it in the if part of an if statement, the else part of an if statement? Here I've explicitly said what's stopping my loop. When I get to the end, what stops the loop is hitting the end or finding the number. This is actually more explicit. This can be analyzed more carefully, because even though to us it looks quirky, to an analysis program, this makes sense. The analysis program knows exactly what that for loop is doing. That for loop is looping as long as it didn't reach the end of the loop and it didn't find the number. Then it keeps on looping. Okay, so it knows exactly what that loop does. Here, the analysis program says, oh, you're going from the beginning to the end of the loop. You're going from the beginning of the array to the end of the array. Then it goes, no, wait a minute. You're not going from the beginning of the array to the end of the array. You might be breaking. Well, when do you break? Well, let's see. We have to go back up here now and look at this if statement. And then we have to worry about if this if statement's inside some other if statement. And it can be impossible to figure this out. Again, if you look at this, it says first, you're going to traverse the whole array. Okay, so all right, you're going to traverse the whole array. Then you go, well, no, you're not traversing the whole array because you may break, but you may not break. It depends on what happened here. And this could be buried in some other if statement. So figuring out what this loop does is actually hard. If the loop is not trivial like this, the break makes it almost impossible to figure out what the loop's really doing. When you put all the logic right there, then all the logic's right there. Okay, so an analysis program can analyze this loop and say, oh, I know exactly what that for loop is doing. It's looping on two conditions. It's looping till it gets to the end of the array, and it's looping as long as it doesn't find the number. Then there's nothing quirky. And then it just notices that there's an empty body here, so it just ignores the body. But it knows an analysis program, or even a human who's reading it can actually say, I know exactly what this loop does, as opposed to this loop where I've got to chase the brakes and figure out how does the brake interact with what's going on up here. That's why I said a minute ago that many companies don't even allow brakes, because they just, like, they don't interact well with the analysis of the code. Okay, so here would be the thing, that the way to write it without using a brake. Put more logic in the for loop.
I got a question about that. So for the for loop, like the variable usually like goes away after the loop's done, right?
Yeah.
So how would it like know what I is at the end?
Well, okay, which in this one here?
Yeah.
Well, okay, see, the I is not declared here, right? So this I'm not sure. So this I is from up here. Is that what you mean?
Oh, okay.
Yeah, see, I can't declare I more than once. So I declared it once up here. So now I don't have to redeclare it down here. Oh, what would happen if I put an int I here? I get a very subtle bug in my program. It's a good question, because you will make these mistakes in your code. So, and this will be what makes programming hard. You'll do little things that make sense, but they turn out to be wrong in the situation you're in. So like right now, if I put int I at line 85, I've now really screwed things up. But my program will compile and it'll run and I'll get wrong answers. What bug did I introduce? By saying int I on line 85, what did I tell Java? What does declaring int I in the for loop do?
Does it change the variable I that you called originally?
I didn't. You were kind of garbled. Say it again.
Does it change the variable I that you originally called defined?
Well, yeah, that's going to be the idea. But what does this literally do? What does int I equals 0 in line 85 do?
It only has the variable exist in the loop.
Yes. So that I disappears there, right? So that I disappears there. Okay. Now, if that I disappears there, what I is this?
It's the one you declared earlier.
Yes. So it's the answer from this for loop. So I would be reporting here the answer from here, because this guy had a different I. But it would be really hard to tell that. It would be real hard to tell that the answer from here was actually the answer created by this for loop, which created an I, looped until it got to the end, and then reported the answer I. Then this guy created a private I. Oh, that's a pun. This one created a private, his own I, looped on it. Then that I disappeared and took the answer with it. The I disappeared, taking the answer with it. And then this I was the wrong I. It was the I from up here. Okay. Now, a minute ago, I said that this will compile. Turns out, doesn't compile. The Java language was designed to try to stop you from making this mistake. So they were actually really clever in the Java language. If you've got an I outstanding, you can't create another I. So, and that for this reason. Now, C++ doesn't do this. So if this was C++ code, I'd have a real problem here. But the Java code was designed to try to prevent you from making this mistake. So when there is an outstanding I already, what we say, in scope, you can't create a private I. See, it's at line 85. Variable I is already defined. So I can't create another I. So Java tries to stop you from making this mistake. So that's one reason why we think Java is a nice language. I mean, I think, a lot of people think that Java is a really well-designed language, where C++ and some of these other languages have problems. This is a good example of a bug that a C++ programmer would spend, would be banging their head trying to figure out what they did wrong. Because they introduce a variable here that hides another variable, and then things get all mixed up. Java won't let you do that. If there already is an I, you can't make this mistake of creating another I, because the philosophy was that's probably not what you want to do. If you've got an outstanding I, you probably shouldn't have another I that hides the outstanding I. C++ says that's fine. If that's what you want to do, fine. That's what C++ takes the point of view. If that's your idea of how to write code, who are we to stop you from writing code that way? Now, more than likely, you're making a mistake, but the C++ language takes the point of view that you never make mistakes. You always do things correct. So anything you're doing is what you wanted to do. Java takes the point of view that many things you do are probably wrong. And if something is probably wrong, it either won't let you do it or warns you about it. It sees you with an outstanding I, sees you declare a new I, and says, that's probably not what you really want to be doing. So it flags it as, in this case, it flags it as an error. Sometimes it flags them as warnings. This one it flagged as an error. So that warns you that you've got something wrong here, and then you weren't supposed to put that I there. Okay, now this I is just this I here. It's just, we're still using that I, but now we're gonna, when we're done here, this I is the answer from this loop, because this loop will update I. So now this I is the I here is the answer from this loop here. Okay, so Java is careful about this stuff. It tries to keep you from making real easy mistakes, whereas C++ doesn't help you a bit. C++ is a very difficult language to program in for reasons, this among other reasons, that it does very little to try to help you find mistakes. Whereas Java was designed to say certain things are probably not correct, so we should flag them. Now, it might be that this extra I isn't really a problem at all. In this case, it was a bug, but it might have been that it wasn't a bug. And I might be annoyed that Java won't let me do that, but more often than not, what Java won't let me do is something I probably shouldn't be doing anyway. More often than not, when Java stops you from doing something, it's something you probably shouldn't be doing. Even though you might feel that it really is okay, it's probably not a good idea to do it that way. Okay, all right. So we've seen 4 ways of doing this now. Go through the whole array from beginning to end and report the last answer. Go from the beginning until you find the answer, then break. Okay. Go from the beginning till you find the answer and break, but report the errors a different way. Instead of using -1 to report the error, use the end of the array to report the error. Okay. Because we got rid of that one variable that's keeping track. By getting rid of this variable, we're using I as the thing that keeps track of where we are. So when I hits the end of the array, that means we didn't find what we were looking for. And then the breaks are kind of, some people don't like breaks. So here's the way to write the code without a break. Okay, so there's the way to write the code without a break, by putting more logic. By putting more logic in the for loop, I can get rid of the break in the for loop. Okay, by putting more logic here, I can get rid of this. And there's a lot of people who prefer that. Put more logic here so that you don't need the break. But that can be tricky. Thinking about what goes here can require some extra thought so that you can get rid of the break. It's almost always possible to get rid of breaks. With more logic, you can almost always get rid of breaks. There's a small number of cases where people have shown that this is something that programmers argue about endlessly. Like, do you really need break in the Java language? So 9 times out of 10 or 9 times out of 100, with a little bit of extra logic, you can get rid of the break. But then there are a couple examples that people created where to get rid of the break, you have to write something so horrifically complicated here that it's not a good idea then. But there's a small number of examples where getting rid of the break requires such convoluted logic in the for loop that it's better to have the break. So the Java language keeps the break for that reason. But it's really rare for a problem to require the break. Actually, they never require the break. You can always eliminate the break. But sometimes, very small number of cases, the logic to get rid of the break is worse than the break. It just becomes really convoluted, complicated logic. Okay, so Java has break in it, and then once break is in the language, a lot of programmers abuse it. It is used more than it should be. Break is probably used by programmers more, and that's why I say some companies don't let you use break. Okay? And if you come up with one of those cases where the break is better than the convoluted logic, you go to your boss and you explain to them why you really think you should use a break, and you might get their permission. You might get their permission to put a break in your code, and you have to justify it though. It would have to be commented, it'd have to be explained, and it'd have to be justified. And that's how real programming works. Companies are very careful about what their code ends up looking like. They can't deal with convoluted, complicated code. It's just too hard to maintain. So they have rules about what you're allowed to write, what you're not allowed to write. And if you feel a real need to break one of the rules, you have to justify it. Okay. All right. So notice that when we do searching, a lot of issues come up. What would seem to be a simple idea, a lot of interesting ideas come up. There's still like, how do you report a missing number? Should you report, like, what should you report? How should you report something missing? We saw the same kind of thing when we did the other thing we did the other day. Which is where were we? When we found that when we did the largest and smallest, we had a similar kind of idea. Remember, this brought up the idea of a non-empty array. Remember, our algorithm only worked when the array was not empty. So again, a simple algorithm, find the biggest number in an array, introduces something quirky like, well, your algorithm doesn't work if the array is empty, and Java allows empty arrays. So simple algorithms can introduce pretty subtle ideas. The finding the max and min introduced the subtle idea of what about empty arrays. Searching an array introduces the subtle idea of how do you report when you can't find something? What's a reasonable way to say I couldn't find something? What's a reasonable way to say I wasn't successful? Turns out that's a really deep problem in all of programming. How do you report something being unsuccessful? That's a general problem in programming. That's actually one of the harder problems to solve in programming. A lot of thought about programming is generally about how do you report that something failed? Like you search for something and you couldn't find it. We just saw a couple things, report the -1 index, report the length index. And there might be other ways. There are other ways to report failure. That's not the only ways. There's, so when you search an array, that's one idea that comes up. And then another thing is like this break. Okay, like what do you do if you're searching an array? Like what if this array was 1 billion items, and you found the item you're looking for at the halfway mark? Well, that leaves you with 500 million items left to go. Should you keep on going, or should you? It would be a lot faster to stop the loop rather than go through another 500 million items. So you definitely want to be able to stop loops. You definitely want to be able to stop a loop, but is break really the right way to do it? Or should you stop the loop with extra logic? Should you stop the loop with extra logic? That's a tough issue. Okay, so little simple problems like these show that programming, that we see interesting ideas in programming even when we do simple little problems. Okay, now let's do another example. Let's go to another idea. Okay. The next idea we want to talk about is mixing arrays with methods. Okay, we want to mix arrays with methods. Now, let me go back to that folder that's on my computer, on the server. Okay, so from class today's date, we want to look at this array methods. So I'm going to want to look at this. So I'm going to download it and then open it and okay, I'm going to open it in Dr. Java. Okay, here's what this is. This is a file that holds 1, 2, 3, 4, 5, 6, 7, 8, 9 methods. There's 9 methods. Here's what they do. And then here's the first method. Here's the second one. Here's the third one, fourth one, fifth one, sixth one, seventh one, eighth one, and ninth one. Okay, or was there 10 of them? Maybe I lost track of counting. Okay, so it's a library of methods. So it's a library of methods, and every one of these methods, there's the name of the method. This column is the name of the method. This column is what it returns. Okay, and then these columns are what its parameters are. So this is a way of telling you this is a dictionary or a table of contents to this file. So for example, the max method takes in an array of integers and it gives you back one number. And what do you think it does? What if max takes in an array of integers and gives you back one integer, what do you think it does?
Gives you the largest number of the array.
Yeah, it finds the largest number in the array. Okay, and what about min? It takes an array of numbers and gives you back one of them. Okay, so yeah, we find the minimum. Now here's one that's not so obvious what it does. This thing takes in an array of doubles and doesn't give you back any answer. But look at the name of it. Can anybody take a guess at what that does? Now, this is something you have to do as a programmer. You have to start making guesses about what people meant by their names. What do you think that thing does? What would ink mean? Can we think what do you think as a programmer the abbreviation? Yeah. Oh, somebody wrote it in the chat. Increment. Yeah. So that's an abbreviation of the word increment. So increment the array, and it says in place. Okay. Well, there's a bunch of numbers in here. What do you think it means to increment the array?
Makes each number larger.
By how much? Maybe
1.
1. Yeah. Increment. It's like the increment operator. See, really what it's going to do is it's going to apply the plus plus operator to every number in that array. We call it the increment operator. So this is going to add 1 to every number in the array. Now, it's not obvious. That one takes a little bit of guesswork. Inc array in place. So that means it's going to take all those numbers and add 1 to them. Okay. Now, but then here's something that says inc array. But this one takes in an array and gives me back an array. What's the difference between the two of them? Now, see, this one's going to add 1 to every number in the array. This is going to add 1 to every number in the array. But why are there 2 of them? Try to reason what could be possible, what could be going on here. The key is this one says in place and doesn't give any answer back. and this one gives back an array of doubles.
Does it create a new array
And does what?
with each number larger by 1?
Yeah, for each number that was in this array is copied into the new array with 1 added to it. Okay, so this one takes in this array, does not change this array. It creates a new array and then puts in the new array 1 more than every number that was in this array. But what does this one do? What is that one actually doing?
It's just changing the one array.
Yeah, the input array is actually also the output array because this thing gets changed. This one's going to change this array, add 1 to every number in it. This one's not going to change this array. The plus 1s will appear in this extra array. Okay, this is a real subtle idea. This is one of the important examples to distinguish between those two there. Okay, now here's a third version, inc array. Okay, inc array takes in one array called the input array. It takes in another array called the output array. What do you think it's doing there? It's going to do the same thing. It's always going to increment, but this is a third strategy that programmers like to use. Notice the thing is I've got input and output. Here in this one, these are my input numbers, and my output numbers are going to appear right. I'm going to add 1 to every input number and make the input the actual output. So I will add 1 to every one of the input numbers, and that'll make it the output. Here, these are the input numbers. I don't touch them. Instead, I give you another array that has the plus 1 of all the input numbers. This one, can we make a guess at what this one's doing?
Does it add a certain number to every element in the array?
Well, it's going to add 1. Wait, it's going to be just like these. It's only going to add 1. All of these increment, their increment means add 1. So add 1, add 1, add 1. But what about this part here? So it adds 1 to everything in the input array. And how would I finish that? It adds 1 to every, okay. This one adds 1 to everything in the input array and does it in the input array. So it modifies the input array. This one adds 1 to everything in the input array, but it puts the result of adding 1 in the return value. What would this one do? It takes in 2 arrays. One called the input array, adds 1 to everything in the input array, and does what?
Does it store them in the other array?
Yeah, it stores those results in the other array. So it modifies this array. So it's a kind of a combination of this guy and this guy. See, this guy stored the results in the input array. This guy stored the results in an output array, the returned. Here, there's 2 input arrays, but one of the input arrays is an output array. The answer appears over here. This may sound wacky to you, and it is, but believe me, this little quirky guy here is actually ubiquitous in programming. People do this kind of thing all the time. I want to sort.
What does that one return?
Oh, we'll have to go. We'll say in a minute what it returns. Okay. We'll say well, actually, here's the idea. This thing takes in an input array. That's supposed to be the one it's going to add numbers to, and it's supposed to put the answer over here. Suppose this array has 10 numbers in it. Suppose this array has 5 numbers in it. Is there a problem there?
Yeah.
Yeah. So this thing returns -1 to mean that there was a problem. If these two arrays don't have the same length, this thing returns -1 to say there was a problem with this method. And if there was no problem, if these had the same length, then it returns +1 to mean no problem. So the return value is what we call an error code. Okay. So the return value is an error code to tell you whether there was a problem or not. The problem being these arrays better have the same length. Now, that problem doesn't appear here because in this case, this method creates this array, so it makes sure it has the right length. And that problem doesn't occur here because the answers are stored right in that array. There's no second array. But now there's a possibility of a problem. This array might have length 10 and this array might have length 8. Well, then you can't increment everything from here and store it in here. There's not enough room. So then you report an error by saying -1. You might still do as much incrementing as you can in the output array, but you report an error over here. Okay? All right, now we'll look at the code in a minute and see how these things are done. Now, what about this?
It finds a certain value.
Yeah, it finds that value. Now, this is exactly the example we looked at a minute ago. It searches for that number in that array. But then what would this answer be?
What index it's at?
Yeah, the index where it's at. But then the documentation has to tell us what, though. Search for that number in that array. Okay, this is going to be the index, but then what do I need? Then what are the two questions I need to have? What does somebody have to tell me about this return value? Two things.
If it's not in the array or if it's in there multiple times.
Okay, so what I need to know, how are you telling me when the number is not found? Are you going to give me back a -1 or are you going to give me back length? That's one question. How are you telling me the number wasn't found? Then what's the other thing I need to know? If the number is found, what do I need to know?
If it's more than once.
No, I don't like, no. I'm going to give you back the index of where it's found.
So just the first time.
Well, I have to tell you whether I'm returning what. What if the number's in the array more than once? I could give you back what or what.
First value or the last value.
Yeah, I could give you the first index or the last index. I need to tell you ahead of time, this thing will return which one. Is it going to return the first index or the last index? If it isn't found, is it going to return -1 or length? Okay, so then that's going to have to be explained later on. Okay. Okay, now here's another search thing. Search for this number in this array and tell me what.
How many times it's in the array?
How many times? Now, here's another search. Search for this number in this array and tell me what.
All the indexes where it's
Yeah,
at.
see, no, so the answer has to be an array of all the indexes where that number is in that array. So now we see an example where you can finally get all the answers. If this number appears in this array multiple times, the answer needs to be an array. So that would be all occurrences, okay? And then this one's just kind of a quirky thing. It just says, build me a random array, okay? Here's how big the array should be, and here's the range of numbers I want so if this is 10, I want an array of size 10. And if this is 20, it means I want random numbers between 1 and 20. Okay, so this is the size. So build me a random array of this size with numbers between 1 and range. Okay, all right. So there's a bunch of methods I want to write, and they take arrays as inputs, and some of them return arrays as outputs. Okay. Okay. Now, this file, okay, I can compile this. I can't run it. This is just a library. It never calls any of these methods. It just says, this is just a way of describing all the methods. I can't run this because it doesn't have a main method. Now I can, what we'll do is we'll put a main method in here so we can call these methods. But normally what I would do is I would create another file and use these, just like you use the methods that were written by the Java language, you can create another file that would use these methods. Well, to keep it simple, we'll just put a main method in here. Okay, let me copy this to the Java visualizer real quick. And what I'll do is I'll put a main method right here at the top so I can. Okay, I'll give myself a main method. Okay, so now I can call one of these. Like, for example, I can do the following. I can say int a, an array equals, and I'll create an array with the numbers. Okay, there's an array with some numbers in it, and I can say int max equals max of a. Okay, so I'm calling that method there with this array here. And then if I want to, now I don't need to, if I run this in the Java visualizer, I can see the answer in max because the Java visualizer will show me that. If I wasn't running in the visualizer, I might want to print the answer. Yeah, I don't really need to print the answer because the visualizer will show me this variable, what answer it is. Notice that I can have a variable with the same name as the method. This plays one role, so that's a variable named max. That's a method named max. Okay, so let me visualize it. Oh, what did I do wrong?
You didn't put a comma after the net or after the one.
Yeah, but I'm getting a weirder error message than that. Server error. Okay, well, now maybe that has, what was the mistake I made?
In the array, you didn't put a comma after the one.
Yeah, I wonder if by any chance that could, let's see, if that could have possibly mixed them up so much that they gave me a weird error message. Or their server's not running today. Their server's not running today.
Yeah, it looks like your code's just too long for the thing.
Okay, now I can fix that by getting rid of the methods we're not using. So let's just delete a few of the methods that we're not currently using. Let's see, I deleted a few methods. Let's see if that is good enough for it. Whoops. Yep, you're right. Yeah, it was just too long for them. So I deleted a few methods and now it's okay. Okay, now let's just real quickly look at this first example. There's my array. See, there's my variable pointing at the array. Now, watch what happens when I call the method. Here's something that's real important. This is why we've talked so much about the idea that I have a reference variable pointing at an array object. I have a reference variable pointing at an array object. Now I'm going to call the max function. And it's got this reference variable called input array. Notice what input array does. Input array is an alias to the A. So my input array notice there's no copy of the array. This is actually the most important idea to show you right now today, is that when you call a method with an array, there's no copy of the array. This is a reference variable. It points to an array. This is a reference variable. It points to an array. When I call this method with that reference variable, the arrow in that variable gets copied to the arrow into this variable. So in max, the parameter holds a copy of the actual value. Remember, the argument, this is called the argument, and this is called the parameter. The argument is copied into the parameter. So that arrow is copied into there. So it's the same array. Okay, now that means that if this method wants to manipulate this array, it's manipulating this array also. If this method manipulates this array, it's also manipulating that array. There's only one array, it's got two names. So if it manipulates this array, it's manipulating the array that this one sees. Okay, so now I can step through this and get the answer. Then when I'm about to return, this will all go away. And I got the answer here. And notice this array is just still sitting here. Okay, now we run out of time. So what we'll do is we'll see that when we get to these three, that's the heart of the matter, is whether we are going to update this array over here. The input array can be manipulated, or maybe you do, or maybe you don't manipulate the input array. Like this one will manipulate the input array. These two won't. Well, this one won't manipulate the input array. This one won't manipulate this array, but it will manipulate that array. This one will create a new array. So the real important thing we want to do is look at these three methods. These three methods are really important to understanding how arrays work with methods. So actually on Monday next week, we'll start with these. And you can look at these over the weekend. These three are the heart of a very important idea of how does the method treat its input arrays? Does it modify them, not modify them, and return a new array, or possibly take one array that it doesn't modify and another array that it does modify? And then this one's the input, but this one acts as the output. So we have to understand all three of these strategies. Okay, and then these are going to be variations on that, but these three here are the real crux of it. These three different strategies for handling an input array. Do you modify it? Do you not modify it and return a new array? Or do you not modify that input array, but do modify that other input array? So the answer, the increment of this shows up in there. Okay, so we'll quit there, and look at these three, and start the reading for methods. We'll be working on that for the next couple of weeks. So we'll finish this on Monday, and then maybe we'll have time to start talking about classes. I'm sorry, and we'll be talking about classes for probably the rest of the semester. Okay, so I'll go ahead and stop here, and let's see. Anybody have any last minute question? Is there anything that's come up? Anybody have a last minute question?
Yeah, I have a question.
Yeah.
My test, you said I accidentally uploaded it as a zip. I resubmitted it as a regular file.
Oh yeah. Thanks for saying. I don't know if I'll be able to get to it tonight. I have another exam I have to grade, so I may not get to it for a day or two.
It's okay.
Yeah. But thanks for sending it to me. Yeah, because that'll make it a lot, and it'll be better for you too. You'll see all the results now up on Brightspace, but it may not be for another day or two. Okay. And okay. So anybody else? Any other last minute question?
Will you be in your office hours?
Yeah, I should be in office hours
today?
I have to go get. I'm gonna go get a bite to eat, and then I'll be back in office hours. Okay.
Okay.
Yeah. Okay. And anything else? Okay. So I'm gonna end, and we'll meet again on Monday. Have a nice weekend. Bye.